Okay, let's go ahead and get started. I'm going to go ahead and do a quick special presentation on Git. Hopefully we can get everyone caught up. Yeah, Git. So we've talked about it last class. Besides last class, have any of y'all used Git or talked about it a little? When have you used it? What'd you do?
Well, I worked in web development at this one.
Okay, web development.
And then I also worked at delivering.
Okay, did you have to interface with other programmers?
Yeah.
Yeah. Did you use Git to do that with the code?
Yeah.
Pretty much, yeah. Anyone else? My previous class? Yeah.
All right.
Besides my previous classes.
And scripting languages.
Okay, cool.
We used it to turn in projects.
Okay, so you have some experience there. Great. Scripting as well? Okay. So if you've done this in scripting or in a previous class with me, it's going to work very similarly. This is going to be a kind of a crash course because I don't have time to go through every single bit of it, but at least we'll get the high-level view of what's going on. All right, version control, very important about managing multiple versions of documents. Pretty much all real projects use some kind of version control, although they don't necessarily use Git. It's very helpful for team projects, but it's also useful for individual projects because as long as you keep committing and pushing to the repository, if you make a mistake, you will always be able to roll back to a previous version as opposed to losing everything.
So what makes it a real project?
So by a real project, I mean, people are actually going to be serious about it. It's not like some pet project you made a little directory on your computer and you're messing around. Usually when it comes like, okay, I'm actually going to do this, people will stand up some sort of repository to help them keep their code, especially if they're going to work with other people. They need some system to collaborate. So that's what I mean in this regard. Some old well-known version controls are CVS and Subversion. Subversion is still well used nowadays. Mercurial and Git are some big ones. Have y'all used any others? Just curious. Yeah, pretty much Git is just taking over right now. Now, the big trick here is CVS and Subversion. Have any of y'all used that back in the day? Back in the day. In previous systems? Not so much. So this is a central repository in that you always worked from a server. Newer repository systems like Git and Mercurial are distributed, meaning that everyone is a server and a client at the same time. So it's a little different way to think about it. We're still going to work kind of like a centralized repository in this class just because it's simpler. But do keep in mind that the reason why some things are a little weird in Git is because of its distributed nature. Okay, why you use it? Gives you kind of a time machine for going back to earlier versions. Lets you also support different versions. Maybe you want to have the main branch, or the main trunk, which is the stable version of your code. Maybe you want to have a branch that has a special feature that you're still kind of working on, but you want to be able to pull updates from the main branch and be able to interface with that, so you can support different versions as you're building this project. Of course, you're working with others, so maybe other people are working on different branches of it at the same time, and this helps. It greatly simplifies it, especially when you're using a good software. Good morning. For getting an internship or job, yeah, a lot of people will look, do you have any type of Git experience or repository system experience? Any company with a clue will use some kind of version control. Yeah, nowadays, I haven't heard of a company not using one. Without, yeah. Okay, why do we use Git? Here we're going to use it to submit assignments and to provide feedback. If you send me your GitHub link when you ask me a question, I can then look at your code, write comments, and then give it back to you in your code. So there's a little bit of feedback that can help you here. Compared to Subversion and CVS, it's definitely more efficient for a modern network. The older versions were built off of older networks which had, I'll just say, different behaviors. Didn't have Ethernet back then. Also, you can go Google why, and I'll give you plenty of reasons. You can always choose to disagree. I'm okay with that. The best competitor right now is Mercurial, which does does all the same things Git does, just differently, is all it comes down to. I could have used Mercurial. Ooh, that's a good spelling. But it's less popular than Git. Git has, if you have problems, take your error, Google it. There's going to be a web page out there explaining you what happened.
It's because it's easier to say Git.
And then Mercurial? Yeah. If you care to Linus, wow, man, this autospeller checker is not a good thing. Linus put up a good video explaining why Git is superior to everything else in the world. Probably because he wrote it, but that's okay. This is actually a good video of him talking to Google and convincing Google to use it, which they do now. All right. Downloading it, just Google online, figure it out. The standard one for Bash and Linux, sudo apt-get install git, hit enter, put in your password, hit yes, wait a minute or two, it's now installed. If you're doing it on Windows, which you shouldn't be here, there's Git SCM and other solutions or packages out there. Okay. Let me tell you the general process when you're working in this class. One, after I add you, fork the repository. I think we all did that, didn't we? Oh, right. So we've done step one. Beautiful. Clone the repository to your machine. Have we done that? Nope. All right, let's go see how that's done. All right, so I'm up here. I'm Professor West, so let me sign out and become my alter ego. Maybe. Sign in. Paul of the West. And let's see what we got. Repositories. Here we are. Let's choose this one. Very important before you clone, make sure it's your name, the repository, and it says underneath forked from. Do not clone the class repository. You will not be able to submit any assignments if you do so. All right, how do you clone? Well, it gives you a nice little link right here. Take this, copy it. Then we'll go ahead and, good morning, bring up a terminal, maybe go to where we want to do it. Let's see, I usually have a grading directory. Oh, I haven't made it for this class, so let me make it real quick. And then to clone it, you do git clone the link, you hit enter, and it says it's cloning, so it's pulling it from GitHub and it's going to grab everything and put it on my machine. Right now, up on GitHub, I have all the lectures and all your labs on GitHub. You should be able to do everything, get all the information you need from the GitHub repository. If something's missing, please tell me. I'm going to do an ls. It's going to call it csci 315. I'm going to just change it on my machine to my username so I know who it is. And then if I do an ls inside of it, let me clear first. ls, knows course materials, lab 1, readme. It's the same thing as what's up here on GitHub because I've cloned it. Yes?
Whenever you get to the location you want it to be at, you just paste and then enter.
Git space clone space that link, let it clone, and then you need to cd into that directory. Okay. Step 3 is to set up upstream if necessary. We're going to talk about that a little later because you need to understand why we're doing it first. 4, always pull updates before starting number 5, aka always do a pull before you start working on your repository just to make sure you have the latest version from GitHub.
I'm very much a fan of number 5.
Do as little work as possible that is still meaningful. That's still meaningful, right? Reason for that, hey, there's no G there. Okay, spell checker, what are you doing? All right, meaningful. In other words, you want to do some work that's meaningful so that you can actually submit it. That way, if you ever have to roll back to it, it's pretty easy to jump back and make the changes. Then commit the changes to your machine, aka think of packaging it up on your machine, then you push it back, and if there's more work to be done, go back to number 4 and you just kind of loop until you're done. All right, that's the general overarching process. I'm going to explain a little more what's going on. So continue the overview. Keep in mind that the class repository that only I may write to is located here. Notice on this link, it says CSU-CS. For your repository, it's going to have your username right here instead of CSU-CS. Any student of CSU group, which should be everyone in here because I've tried to add you to it, may read from it but not write. A fork creates a completely separate repository up on GitHub, and notice that is located very similarly, except again, it's your username down here, for example, Paul of the West. Keep in mind that both repositories are independent on GitHub. Here's a better picture that should help you out. Up top, you can think of GitHub's infrastructure, all their server machines, and there's the course repository, there's your repository, and then via the internet, we can have your machine be a clone of that repository. Now, very important, this machine that's yours can be any machine. It can be what's sitting in front of you. It can be a home machine. You can be over in Europe and download it as well. Whatever, don't care. As long as you have an internet connection, you can go clone it, move it on your machine, do work, push it back up, and everything should work just fine. There's an autograder that also is connected to your repository. It exists in that room over there behind us in 209, and it has permissions to actually grab from your repository and read and write from it as well. All right, any questions about the architecture? Good? All right. So when you created the fork, it copied the course repository and made it into your repository. That's all it did. When you create the clone that we just did, it copied from your repository, good morning, over the internet, over to your machine. By the way, stop me if any of this starts being confusing. At some point, the autograder will pick it up, and we'll get into that a little later, and create another clone of your repository on the autograder. Okay, so there's two clones, your machine and the autograder. When you make changes to your code, git add tells Git what files to put into a commit. A commit bundles your changes into a package to be sent somewhere. This all happens on your machine. It does not go through the internet. It all happens on your machine. So git add and git commit does not submit any of your work. It just packages it up and prepares it to be submitted, is what it does. Now, why are these separate? It has to do with Git's distributed nature. Add tells Git which files you wish to package. Commit actually creates the package of all the files that you added. So you may only want certain files to be in a package, so that's why you use git add to put them in there. And then commit is what actually creates that bundle. And you can create multiple bundles before you push them. You can create 10 of them, 20 of them, and then finally push them up later. And that's perfectly fine. And the reason why Git does that is so you can actually pick and choose which commits you actually like in case you don't like certain ones. Okay, but for now, you probably want to think of add and commit as a similar operation, which is fine for now. Git push actually takes those changes and pushes them to your repository. Quick question, are your changes in the course repository? No, they're on your repository, not the course repository. And that's fine. If the webhook is installed correctly, which we haven't talked about yet, the autograder will pull your changes after you have pushed them down to the autograder. Once those changes, after running some tests, because it recognized you pushed to it, it will push a grade.txt file up to your repository inside your lab directory, and that should give you the details of what your grades are, and maybe some hints about what's going on. This process in general takes less than 10 seconds, but if the internet here at CSU is not doing too well, it can take a minute or two for this to happen. But that's still way faster than you emailing me, and especially if it's Friday. All right. Then you can, of course, git pull to pull the latest from your repository. Notice after your push, at some point the autograder will push their own changes to your repository, so you need to pull that change back to your machine. Okay? That's in general what's going on when you submit your assignment and you want to look at your grades. Are there any questions about this process, about the process so far? Okay. Can anyone see an issue that might be coming up? Oops, I gave you the hint. What happens if I make a change to my repository that you need on your repository? What's that?
Upstream master.
Well, okay, so anyone's had me before, I call it upstream. But if I make a change to my repository, does that change on your repository? No, because they're separate. So in order to do that, remember this is a regular git pull. When we set up upstream, you do git pull upstream, it will pull from the course repository onto your machine. Now, does your GitHub repository now have the latest?
Did you push it up?
All I've done is pulled from upstream. So no, it does not have the latest. Because notice I've just pulled from the course repository onto my machine. I haven't done anything yet. What must you do in order for your repository on GitHub to have the latest? Or have my changes?
Push it.
You need to push it from the machine that you just pulled upstream from. So you need to git push, and then once you do a git push, I didn't arrow this, but it would come up here and then back up here. And then your repository would have my changes. Okay? So yeah, this is why upstream is important to hook up. All right, let me make sure I covered everything that's important. To make changes, you must clone your repository, not mine. Then make changes to your clone repository, which you've hopefully forked. Since I'm the owner of the CSU CS, I can read and write to any forked repository, namely your repositories. If the autograder is up, which I will try my best to maintain it, you will receive an autograde shortly after pushing. Usually it's 10 seconds, but if you have network issues, it might be a couple of minutes. Or if it's not hooked up, if you don't have your webhook set up correctly, it's not going to work. When I make changes to the class repository, you have to manually get the changes via git pull upstream master. Okay. Let me show you at least that portion in action, because I have Paul of the West CSCI right here, and if I were to click and open up the course repository, you will notice, once it loads, that there's a lab 2 directory over here. But over here I only have a lab 1 directory. So my repository is behind the course repository right now that I forked from. So that's why we need to do this pull upstream to master right now. So let me go ahead and show you how that's done, because I didn't write those in the slides. The first thing you must do is go into your repository, not the directory above your repository, into your actual repository, the root directory. And I think you can usually do git status. Good. When you do that on branch master, perfect. Your branch is up to date with origin master, nothing to commit, working tree is clean. Good. So you're ready to go. All right. How do you add this? Git remote. What was it? Git remote add upstream. And then up here, that's where you're going to want to go over to the course repository, clone, and then copy that. Upstream, yeah, there we go. Notice this one has the course repository, not your repository. If you try and add yourself as the upstream, it's not going to work. Okay. Okay. If you do git remote, you have origin and upstream. That's great. So now if we do git pull, that's going to pull from my repository, but there should be nothing there, so it should say everything's good to go. Wow, this network connection is not doing well today. But if I do git pull upstream master, it's going to pull from the upstream from the course repository. Hey, look, it added a bunch of files. Look, it added lab 2, and it looks like I updated some slides as well for the latest editions. Yes?
Once you do the git remote add upstream, and then you copy the
Courses.
course repo, then what do you type? Do you just paste it in?
Yeah, just hit, paste it in, hit enter.
Or do you have to type remote add upstream? and then
Git
paste?
remote app. Yeah, so here, let me show you which command was it. The command was that one. Git remote add upstream. That whole thing.
And then what do you do after that?
You just hit enter.
So if nothing happened, then it worked, right?
Yep. Then later you do git pull upstream master. And that's what I just did, where I pulled all my changes from the course repository. Because upstream is the course repository when you've set up upstream correctly. Now, still notice that even though it's on my machine, if I were to refresh my repository on GitHub, you will notice that it still only has the lab1 directory once it finishes refreshing. There it is. But in order to, because I need to, very important, push my changes back up. So git push, and that will push it up. Yes.
So in this case, did it just push? Did you not have to commit it?
No, because it pulled all the commits. So pulling commits is what I'm really doing.
So mine keeps saying the repo is not attached.
You need to CD into your repository first.
Okay, because I'm at the GitHub area, and now I'm trying to clone.
You clone. Now you've cloned it. Now
It's not
CD into
cloned.
that directory you just created.
It's not letting me clone though.
Oh, so that's a different. What's the error it gives you there?
It just tells me the repository doesn't exist.
Then so then it was typed incorrectly. Are you putting in your username and password?
Yep, I'm trying to copy it, it won't let me paste
Okay,
it.
so you'll have to give me very lab time. Yes.
So I did all that and pushed, and it's not the same. It didn't like copy it all.
So let me go back and check. Let me refresh on mine. And now I have lab 2 up here. All right. So obviously y'all are going to have some errors. If it's not working for you, you can't get it to work, please grab me during the lab time because I do unfortunately need to move on.
Oh.
All right, hopefully you've all joined. You've probably gotten an email to subscribe to it. Click on it. You'll see something like this. Notice the CSU signature. Actually, I've talked about all this in my slides. We already did forking yesterday, so that's great. And then you should eventually see your repository. Awesome.
So our repository should have lab 2 as well now?
Should have what?
Lab 1 and 2?
After you've done adding the upstream, you've pulled and then you push, yes, it should have it.
Install. What's the command for installing?
Sudo apt-get install it, yes. You gotta spell all that correctly. Let me see. So actually I have the slide up here, I believe. There it is, right down here, up on the slide. All right. Any questions about the process? Anyone confused about the process of what's going on? Are you confused about your course repository and your own repository? That's the big thing. You gotta get the concepts in first. Okay, people understand the concept? All right, so when you're gonna start having some issues probably with upstream, we'll pause here for now. I'll help you during lab time. Hopefully we'll get to more lab time later on in this course, or later on in this class today. Okay.